That's the way these things go. That's why I always try to avoid actually going down to the main lab. And people know I'm here, then they ask me to do stuff.
Try going into the building.
Yeah.
Before I ever get into the building. Oh, musical building.
Yeah.
Doesn't matter where.
So you're still between the two buildings here?
Yeah.
Will you continue to be that way once the...
Yeah,
I'll
we're going to do the same thing.
Okay.
So,
Because it's good and bad. It's a change of atmosphere.
yeah.
So the same place, 8 hours a day.
Yeah, definitely.
Well, it is 8 hours a day, other than Friday. Yeah. She'll, we'll switch. I keep my same schedule, and she takes the off days. So we'd be here on Tuesday, Thursday, Friday morning.
Oh, so you come from CSC on Monday.
Yes.
Or can I remember if someone's like, do you know what Karen did? I'm like, no, but I'll look her up on Break 500 or whatever.
Right.
Is it still listed there? I don't know that I always do the right thing on that.
Well, or the directory, I should say. I just go to school and keep calling it Break 500.
I keep trying to, is it right though? I don't know if I always put it wrong.
They never come back. So, I'm assuming they either found you or they gave up finding you.
Is they
This is day 13. Lucky number. Okay, so let's get going. So today we're going to finish parsing the columns, and we're going to stick these things into variables, and we're going to print them out. So okay, just a reminder of what the heck we did last time. So we start writing programs by breaking the problem statement into a few simple steps. And that means that each of those steps is still vague, just like the problem statement was. But then you continue by breaking each of those steps into sub-steps until it's not so vague. And so you have to be comfortable with vagueness to get started.
I'm not so good with that.
And
I already feel vague.
we'll develop your skills in that area. So, eventually you stop when you think you know how to code each step. And then you start coding. And you usually pick the lowest level step and the one that you're most unsure about, if there is such a thing. Because that will determine if you can change the way you're doing things. You can't figure out how to do that unsure step. Sometimes that happens. You think you can do something, no, I can't really do it that way. Plus, maybe Java, there's a million languages you can choose from, but maybe you haven't seen. Okay, so then as you code it, you test each piece, make sure it works in a bunch of different cases before you try to build more code on top of it that uses it. Because otherwise, it ain't going to work. And there's no chance of it ever working unless you make sure you debug it and get it working bottom up. So then you just keep doing that till you're done, and hopefully it kind of works. So, as you remember when we left off last time, we were doing string toke, this function that, again, the compiler writers wrote for us that helps us turn a giant string into a bunch of little pieces using a delimiter, in this case, a comma. And so we got like the first column, we did this, return string toke line comma. And then to get the second line, we did something like this. We did string toke line, and then we did return string toke null. That's how string toke wants you to do it. And it's kind of kooky.
It's not avoiding it.
But it works. So then you could get the third column by just adding another string toke with null in it. So everyone but the first is null. The first one is line. And until you're done, however many you think there's going to be. That's something you kind of have to know the data. You just keep doing this over and over again. And each time, a different token is yanked out of it, basically. So, one way of programming this is to just do this. Column 1 is this thing with input string. Then all the other columns, in order, are just one after the other, string poke with null. Over and over and over again. Each time pulling out the next column. And in this case, since they've already written string poke for us, it's easier for us to not use a custom function call, which is what we were doing last time. So
What's the custom function
remember
call instead of?
remember what we were doing? We would get first column, and it would basically just do this. So it's kind of pointless to have it just do that. We might as well just do that.
Right.
And the heck with a custom function call.
Gotcha.
So if they hadn't written this for us, it would make sense to have a function call. Since they did, now it's basically one statement to get each column. That's pretty easy. I think I'll go with it. So just to remind ourselves where we are in the program, we're right here. We're trying to read the separate pieces of the string into variables using string poke. We've got all this yet to go. So let's make sure we finish that step. Right now, this gets it into a bunch of variables that I just made up at the moment, and each one of these is a string. That's what string code does. It makes everything a string. Start with a string. Each one of these is a string, which isn't really what we want. So remember the columns in the input file. We had username, which is a string, user ID, which could be a string or an integer, the machine number, which could be a string or an integer, and then all these things, number of copies that are black and white or color, and those are strings, but they can certainly be usefully described as integers in our program. So deciding what to call, what type to give these is an important topic. And let me talk about that. How do I talk about that? Where is it? Here it is. So, for example, for user ID, it's an integer, really. But it's also kind of a string. Everything's a string, really, when you get down to it. But it could be interpreted as a string, a real number, an integer, whatever you want, depending on what it is. So for user ID, it's an integer, but it's kind of a strange integer because it kind of starts with 0. I can't remember if you remember that, but kind of like 0, 1, 6, for example. It's an integer, but it starts with a 0. So it's starting with a 0 is important in the problem statement. If you remember, part of what we said was only bother printing stuff if the user ID starts with a 0. So because of that, it's actually treating the user ID as a string, not as an integer.
Stop for just a second.
Yeah.
So in all of what we're discussing in particular is relevant only to this coding problem, not in general if you have something that begins with a 0. It's only because user IDs are very specific and it's this. Okay.
Exactly.
Okay.
Yeah.
Okay. I just
But
want to make sure.
it's an example of the kinds of things that you will
need
run
to
into.
consider. Okay. Okay. I just want to make sure.
And so that, if they didn't care
Right.
about it starting with a 0,
Okay.
and all they cared about was the number, then maybe it would make sense to turn it into an integer.
Okay.
But
So
since
it's
they
the kind of
care,
thing that you need to ask and consider
Yeah.
as you're
Exactly.
applying your coding.
That's right.
Okay. All right.
So for each one of these,
All right.
we had to think about what makes sense for this type.
Okay.
So these three, I decided to just leave them as strings, just the way they come out of string code, because we're not really treating them as
Calculating
numbers. I
anything.
mean, username, certainly a string. User ID could be one or the other, but based on how we're using it. Let's leave it a string. Machine num, we're not even using machine num. I don't know if you noticed, but we're not using it at all. So just leave it a string. Fine, whatever. These, we care about them being numbers because we're going to turn that into a cost in some place. So we have to calculate with them. So they better be numbers. Okay, so here's a little code snippet, which is just all these, just this little piece of stuff. Did I turn this on? No, not yet. Turned on my, yeah, it's gone. Okay. So this is just a code snippet. We declare each of the things we want to read in. Then we show the code similar to what we already did back here, but using real variable names now. So we set the username equal to the first column. We set the user ID equal to the second column. Machine num equal to the third column. The number of black and white copies, fourth, and so on. So now we have meaningful variable names that these things are getting assigned to. So that's all we did. We just declared them and used them. And this is the same as what we already did. So, one last issue. Since string toke returns strings, we can't really get away with this right here. We can't assign a string to an int. This is what this is doing. So, these four are wrong. What do we do? Well, it turns out that there's a function called a2i, which usual be trying to not ever write anything out but abbreviate a piece of code. It's converting a string to an int. That's what a2i does. And it's very similar to scanf. If you remember scanf, we would tell scanf to read from our console where we were typing, and we would tell it that it's a string or it's an int or it's a real number, and we'd give it this and variable type thing to tell it which variable to dump it into when it read it. And that would convert, which essentially is a bunch of characters that we type, into variables of different types.
Why isn't it S2?
I know, it's dumb.
Really?
It's really dumb. It's really dumb.
But what's the A?
It's really dumb. And you know, if you can't stand it, you can always write your own little function called string to int, which just calls it I. And then use string to int from then on. And I highly recommend it. I mean, because it's stupid. There's a lot of these things that are just stupid. But, and it's your functions, right? You can do whatever you want. You can name it whatever you want. Because you have the power.
Might have to just
But then you're just kind of
reinventing
so much
the wheel.
information, formulas, and all these
But then it makes
things all over.
sense.
But yeah, it's easy to remember that way.
Yeah, definitely. And you can read your code and it says what it's doing instead of whatever the heck that is.
And remembering A2I.
Yeah. Now, of course, real programmers will just hunker down and say a2i means string to int, and it will be encoded in their head.
Yeah, well,
And they'll just
I don't
use
have
it.
room for things that don't make sense.
Exactly. So the big difference between a2i and scanf is that scanf is much more general. And so instead, a2i takes a string as input instead of like reading from the command line. And a2i assumes that there is one integer waiting to be read, whereas with scanf it could be a whole bunch of stuff, right? And it just returns the value instead of dumping it into some variable like scanf does. So it's a highly simplified version of scanf, made just for this situation. So here's how you use it. Say, for example, you've got a string, in this case 10 characters, so you just get hello into it. And you've got an integer named num. You can just say num equals a to I string. And that will get you, in this case, 56. Stuff into num. Why the heck, what did it do with hello? Right? Well, this thing is smart. It says if there's something there that couldn't be an integer, couldn't be part of an integer, then it stops. It just stops. It says, I'm done. And whatever I've done up till now, that's the value that I'm going to return. So if this had started with hello, you just get garbage. But since it starts with an integer and ends with hello, it just stops when it gets to H. So even if there was more digits after the H, it wouldn't even look. It just says, yeah, you're done. So it's very simple, very straightforward, very dumb. Just the first thing that couldn't be part of an int, I'm done. So it's actually very simple to program. You could do it. But for now, we're using with H. So okay, so let's add in our calls to A to I. So that's these guys right here. So we just shove A to I in front of string toke, kind of enclosing string toke. So the string toke is returning a string. So we'll make that string be the input to A to I. So we don't have to assign string toke, this thing to a string, and then stick the string into called A to I. We can just use the string directly and call it A to I. And we can do that a lot. We can nest functions like this a lot. And it can make things a little easier to deal with. Now, whether this is readable to somebody else or not is another story. And that's up to you to decide. Readability is a personal thing. Perhaps somebody would much prefer setting string toke blah equal to some string variable and then doing A to I in that string variable. But this is the way I do it. I can read it this way. I know what it means. You do whatever works for you. So this at least should compile. So now we've got all the column names of the input file, all typed. We've got all the column names set to something, assuming that we've actually read something in the input. So let's do it.
Yeah,
Okay?
Right.
So make their day 13, cd into it, and let's Emacs test1.c again with the and, so that, again, because we're still just testing stuff. And here's the program. It should look pretty familiar, because it's pretty much just what we just did, except for forcing some test input strings and then printing out what the heck happened, just to make sure that it really did work. Which is what testing is all about. Set up some input and make sure you output what you did. And of course, there's the bug. So, keep you on your toes. Fun to see your faces.
Like, just see it, and it looks quite right,
Only
but
I
I
had the
don't
camera
know.
looking this way. It would be a lot more fun.
Just that.
I imagine I look the same.
I don't think
He ain't brown.
by the way, I'd like to tell you a story while you take these notes.
Okay.
When I first wrote this program Sunday morning, it didn't work. And it wasn't this program, it was a version of this program. It didn't work, and it really didn't work. So I had to go back and throw it out and start over. And so even after 35 years, you can still do stupid stuff.
So was it a random or?
No, it was a complete misunderstanding and lack of remembering, if I do understand it. Lack of remembering how Springfield works. So I completely misused it.
This is helpful for you too.
It isn't. That's why I'm doing it. I am trying to figure out how to teach. And, well, remembering how to use Springfield too, I suppose. But, another part. Learning how to teach.
Teaching is difficult. I mean, I don't
It is.
teach, but I
mean,
No,
it is. I
it's-
mean, clearly, 16 of the 18 people that started weren't particularly interested in continuing. And, they all had good excuses. But I imagine if I'd been a better teacher, they'd still be there. But who knows?
no.
I think it's just subject.
What?
Subject matter.
Yeah.
It's not all that interesting,
Jean
truthfully.
is the only one who said that it was just too crazy for her to put her head around.
It's just not. It's for, it's, I
It
actually
isn't.
have thought about taking programming for a long time just to see what it was and how I could possibly use it and
Right.
to try and understand where our students were coming from and just all kinds of things. And
Right,
I pretty
right.
much don't.
I mean, for me, the only use for programming is to save me time.
Right. And I don't have this much time to dedicate to saving time.
I
You know?
understand.
Yeah, that was.
I understand.
Yeah. But I now at least can sympathize a little with
Right,
our
right.
students, or
Yep.
maybe identify in some way.
Yeah.
Oh, I kind of about how much homework they
Yeah.
have and what's on their plate. I mean, I know they're very.
Dumbed down.
Yeah, they're very overwhelmed. Every time they graduate or descend, I'm like,
Yeah.
oh, you made it. Can't imagine what that would be like and all that you've been through.
Right.
So how we doing?
We're
Getting
slow.
there.
It's on tight.
Yeah. Very good.
So are you compiling?
No.
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 Mull doesn't work.
No,
It did. Sometimes it's useful. The colors.
the operator was.
If you want to look, there's some other colors that don't make sense while you're at it. Alright, now it's worth trying.
It's so easy to pick that right out.
Yeah. But if the colors are wrong, it really helps to have the color on here.
Yeah, it's smart that whoever thought to do that.
Yep. It's pretty useful.
Someone was good.
Yeah, someone whose eyes were getting bleary looking at this crap all the time. It still thinks there's a mull. Is that right? No. It compiled. It compiled. She knew what the bugs were as she typed it in.
Look at that.
That's
Good
impressive.
girl.
Well,
That
it was
is
almost the same
impressive.
as last week.
There was one that was exactly the same, and there
Okay,
was one
'cause
that
I'm
was
like-
different.
That doesn't feel right.
Yes.
You know, when
And
we
that's
women,
good.
we women get these feelings
No, that's
for
good.
reasons.
Yes, that's good.
Do you agree, Karen?
Yeah, but
I-
I apparently don't have the same feeling as you.
Oh, I did. I remembered that feeling from last week.
Inch by inch. All right. That looks promising. So what do you think? Shelley, is that right?
Well, I'm just thinking of, like, Jennifer. Yeah, I think it is. I'm assuming that you had 38 by my copy. Sounds like
Well,
a print.
All you got to do is program this. You got to look at that
Yeah.
and see if that makes sense. And it's basically the same thing. So
Besides the one, I found the
besides
38.
the machine nub, which we didn't bother printing because we don't care. Right? We don't really do anything with the machine nub, so we didn't bother printing it.
But if we wanted the machine number,
You
we
could have.
did.
You could have printed it. I mean,
AT.
we read it in
A to I.
because we have to read every column. We read it in, but we didn't bother printing it. That's all. And it's it's a string. You can still print it in a string, even if you didn't convert it into an integer. It looks like an integer. It still looks like a string too.
So Jennifer were to do this. I mean, this is the tip of the iceberg. She were to
Exactly.
tell the
That's it.
machine, go get everybody and
That's
do
right.
one great big JE and charge it.
Right,
Or
right,
whatever.
yeah, and she
Seems to
actually
be-
ends up generating, I think, 3 or 4 different ones that she gives to Gene,
Yeah.
who then does the charging.
Yeah. And we get copies of all those JEs and And if you don't disable the macros on those, it's just all this, it's,
From that one.
yeah. Don't enable them. Then you wait for it to all pop up, flip it all back down, and then disable the macros. Which sometimes you don't want to disable them. 'cause
Yeah,
you
yeah,
use them,
exactly.
you do- but not on the ones that Gene does suggest. And why, I don't know. I just know that whatever comes from that data, disable them. Whatever that is. No, scientific explanation other than
It works.
they popped up all over my screen enough times over the years.
Yeah, exactly.
So is the error so I did my
Okay, so line 13, input string undeclared.
Mhm.
Go to line 13. So if you just need to click. You
Okay.
just need to click and it'll tell you line 13.
Gotcha.
So input string.
Mhm.
And what did we declare? We declared input string.
Okay.
So what's the difference between those two?
I don't know.
One has
Oh,
an underscore
underscore,
and
gotcha.
this one doesn't.
Gotcha.
Okay. What else?
Alrighty.
What other errors do you have? Too few arguments to function string tote. That doesn't look promising either. So input string you dealt with. So the next one is this one, line 17. So go to line 17. Machine num string tote null. You've got a extra paren after the null instead of a comma. Well, you got the comma too. So that's good.
Okay.
I'd save it and try compiling it again, see what happens. And you don't have to type it in.
Oh yeah,
Remember,
it's just a
up arrow thing. Alright, what does this say?
That's because I'm doing the 0 instead of out. Right?
So yeah, so what the heck?
But why did it do it
Oh.
first time?
Yeah, good question.
Huh?
I don't know. That looks good. Woohoo!
Woohoo.
Alright.
Okay.
So go ahead and run it.
Okay.
Alright. That looks pretty promising. So those are all 38750. It's close. Something's screwy. Let's see. 38. You got 38 twice.
So I have a D period.
You've got num BW copies twice.
Okay, and I've also got a D period.
And you got a period instead of a comma. Details.
Details, copies, and copies and
copies,
prints.
prints, copies, prints. It looks like you just got it extra, so I just get rid of one of them. Yeah. Like that.
And then I can still do it with the last.
Compile again.
Okay.
Just compile again. Let's go back twice. And then go back. 38750. 38750. That looks pretty promising. Okie doke.
Okay.
Alright, so it works. Some comments, which I didn't include anywhere. Why did we do it this way? Why didn't we just use scanf like we've done in every other program? Why did we use string totes?
Because we have a whole bunch of
In part, that's why.
things to get out and put out. Like again, there's probably a couple hundred numbers in those machines, I imagine.
Yeah, for a real one,
Minimum.
for a real one, it's
So-
huge. It's huge, certainly.
or columns.
Yeah, like you could have your percentage or your
Yeah,
this,
yeah,
you know,
and it
and
really
there's
is.
how many
It
faculty,
really
how
is
many
a zillion
staff.
things, yeah. I simplified it from the reality of what it was, so that it was not too difficult to deal with.
Because of that.
So, the real reason is that the input data consists of strings and numbers. And using scanf with strings will tend to just grab the entire line as one string. And so there's no way to tell it what part of it is the string. With numbers, you can. With numbers, if it's not a number anymore, and it's obvious that you're done reading the number. With strings, anything can be there. So the whole line basically would get read as a string if you tried to use scanf with strings. And that's why we never, ever read strings with scanf. Because it doesn't really work.
Will define string for me again, please.
So, a string, it's an array of characters. In this case, like here, we've got 100 of them. So
Well, you could have said 500 there.
we could have
Just
said
said
500. We could have said
1,000.
1,000.
Just
Five.
Yeah, yeah.
just
It's just a whole
characters.
bunch of them.
Doesn't
It's
matter
just a
what
whole
they
bunch of
are.
them right in a row, so that you assign something to it in the same, like the contiguous hunks of memory are all the same variable, and they just get characters assigned to them sequentially.
But you need to be able to, in some circumstances, define that string in either. Those characters have to be characters or specifically numbers in some cases.
Right. So the whole idea behind stringtof is you can say, I've got a bunch of stuff in this giant character string, and some of it's string, some of it's numbers, and they're separated by commas. So now it knows, okay, when I hit a comma, that's the end of
Of
something.
that, something. Okay.
That way, it has a chance of knowing that your string is done. And that's
Okay.
how this first one works. The username cannot have a comma in it. So when this thing hits a comma, okay, we're done. That's the end of the string. And so, in general, in every case with strings, you need to kind of know where the end is. That's why when we do this, we need to make sure that it ends with a null inside our code, so that it knows where the end is. So the character is a character is a character. Any character could be in your string. So now it's defined, okay, null will end your string. Or stringtof, comma will end your string. And put anything there, just put a null there if you felt like it. You know, whatever works.
So the input string 100, if you just put like 8, would it stop reading after 8 characters?
If
Or
I
would-
did 8, we get into something that's called a bug, a serious bug, something that I've avoided talking about. But I'll tell you what happens. So we've got memory. We've got a big chunk of memory somewhere, and all our variables get dumped into this memory. And let's say each one of these is a single byte. Remember, characters take up 1 byte, integers can take up 4 or 8, real numbers can take up 4 or 8. And so when we declare stuff to the compiler, it goes and it says, okay, input string 100. So let's just say this is 100. And it'll say, okay, that's input string. And it'll remember what number this is. Maybe this is 101, 102, you know, you've got to number everything in memory somewhere. So everything has a number, on and on, right? So it says, okay, those are reserved, those are input string, and away we go. Then you say, oh, username, so, you know, it comes up with where username should be. And the next one, user ID, comes up with what that should be. Then machine num, it assigns some hunks to that. Number of black and white copies, it assigns some hunks to that. And it just does this sequentially. It just fills up memory with whatever it is you're declaring. And it remembers where all these starts are, so it can go back there when it needs to and grab stuff and put stuff. So it needs to know where this is in memory. So that's actually what the variable name is all about. It kind of remembers where it is in memory. So what happens if I try to assign more stuff than what will fit? So basically what happens is this. It just fills it in, and then it puts a null. when it's done. It just does what we tell it to do. So it knows where we start, and it just dumps everything in, and then puts a null when it's done. So what it has done is, if there was anything in this variable, or this variable, or this variable, it just got overwritten. Unintentionally. This is bad. Really bad.
It's because if we told it to only use the first 8 facts rather than 100.
So
So we really just want to shoot for 100, just so we have plenty.
Plenty,
of
exactly,
space.
plenty.
Or we could do 1,000.
So if
even
you
with
ever
the-
do
with the-
something like this, and this is less than that length, you have just screwed things up so bad, you need to give up now, basically. You have posed everything,
That you had in the,
all these variables are potentially hosed.
So 100
And
is
that's
just a nice.
really, really bad.
Yeah,
100
it would
for
be
now,
perfect.
100 for now is just way bigger than this.
Is it like a random number?
For now, it's a random number. In the future, we're going to make this much bigger when we need real data, because real data can be really, really long.
So we kept it small now.
And we won't use this. We will graduate to something that's slightly different. And this function is practically the same. The variable name, some string, and then a number. This is when to stop. So if this thing is only 100 characters, and this number is 99, don't copy more than 99, or you'll screw up my memory. So this is what you really want to use, always, actually, so that nothing ever gets screwed up. But for now, we're keeping it simple, and we're using string copy.
So if we put 1,000 up in that number instead of 100, it would take a little bit longer to compute, or that's how we try to keep
No.
it more.
No.
Okay, so
No, it
I
wouldn't
don't know why I'm
take
stuck on that 100. I
It would
just want to know what the
It would just use
reasoning-
more RAM.
Okay.
Yeah.
so actually, when I was talking about that I always wanted to take class, the basic computing class, like I would like RAM on. Of course, I don't necessarily know what all of the acronyms about computing, however,
Yes.
you know, that.
And have to help you.
Hmm?
That's me. I've taught this course.
Yeah.
Have to know.
Yep. That would, it would
So-
just help, I think, as well. You know,
So,
I've heard it 100 times, but.
RAM. RAM is memory where your program lives, basically. And it's separate from the hard drive. And it's 8 gig, kind of, maybe 2 to 8 gig, somewhere in there, whereas your hard drive is 100 gig, terabytes, something like that. So RAM is random access memory, but it's basically fast memory. Hard drive, like I said, I think second, somewhere in there. A hard drive is like 100 to 1,000 times slower in accessing it than RAM. And so they created RAM so that programs could run faster. And so RAM is special memory just to be fast so that your program has a chance to run quickly. Everything was on the hard drive. In the old days, everything was on a floppy. And it's all slow. Back then, everything else was slow, so it didn't matter. But as everything got faster, you had to make memory faster. So RAM was.
So it knows to run it stuff on RAM rather than run it stuff on the hard drive?
That's right. I mean, that's one of the things the operating system does for you. You have a file called test1. It's an executable file, and when operating system runs it, it takes it and dumps it into RAM. And then it tells the CPU to start running that first executable statement in that spot in RAM that has the stuff. And so everything is in RAM, other than when you like read and write to the hard drive or the console or something. So it has to kind of go through
Like when we save our files to our hard drive,
To
obviously.
the hard drive, right?
When our professors buy new memory, they want more RAM
They want more
to
RAM.
run whatever they're running quicker.
And usually more RAM means a computer program can run faster, usually. It depends on the program, of course. Your programs, for example, are small enough that it doesn't need more RAM to run faster. But there are lots of programs where it can help make it run faster.
But then they have to save their program to the hard drive, so just run on the RAM. Is that what?
All the
you know, that
programs,
was like,
all the
save
programs
this?
that you have and anybody else has, they are saved on the hard drive. But when they're running,
They use
they're
RAM.
in RAM.
But they could run on the hard drive. Just
I don't
They
think
won't?
anything is ever set up for that these days. I mean, other than virtual, which we aren't going to talk about.
just trying to get a whole separation of like, you hear them order computers and they want this
Yeah.
gig and megabytes and I'm like,
Right.
okay, it sounds like a good one. And, you know, I
Yeah.
never know.
And a lot of the programs that the kids use, these GUI things that are generating all kinds of data, these things usually mesh something so that they can calculate in more detail. And, you know, what the heck's a mesh, right? Well, just think of it this way. I mean, they've got some geometric objects, and they're dividing it up into little teeny pieces in order to be able to calculate something about it. And often they need the pieces to be really small to make it accurate. And so that's a lot of pieces. Each piece requires a significant amount of RAM, multiplied by 100 million, and you need a lot of RAM.
Mm-hmm.
So a lot of these kids need lots of RAM in order to make these codes they're running work better, faster, and with more detail. And sometimes you can't do it, right? You're a kid, you've got whatever RAM you've got, so you mesh to whatever your computer can handle, and you see if that's good enough. If it isn't, then you go beg your professor for a better computer, or maybe
Buy more memory.
time on one of Kane's computers that has a gigantic amount of memory or something like that, which can be painful for other kids want to use it as well. So it's always nice having it on your computer,
Yeah.
so you have complete control.
Are you limited to how much, if my hard drive is only this big, can I only put so much RAM?
No,
It can only
RAM and
handle
hard
so much
drives
RAM?
generally aren't related to each other.
You know, like my car can't pull a camper, but my husband's truck would. You know what I mean? Like the
Yeah.
hard drive.
Pretty much the
But-
motherboard determines how much RAM you can put on your computer. The motherboard is designed with a certain range of possible RAM in mind, and it can't handle more. And it's actually kind of a pain. You might have an old computer and you think, oh, it's good enough, I'll just shove more RAM on it. You can't shove more RAM on it. It's got as much as it can handle.
So you guys really have to know if you're doing a big program, what RAM
You do.
you might
You
need.
have to
Because you got to
understand
make
all
sure
this.
it runs the programs you're writing. Or because the computer won't say, oh, sorry, need more RAM. Oh, your motherboard's too small. Sorry, need
Yeah.
more motherboard.
Yeah,
Or-
none of the error
or,
messages
you know what I mean?
are
It's
that
not that.
conversational.
Yeah, that conversational.
They're usually,
You just hit-
general protection error, and the thing
And then
dies.
you'll be like, oh, okay, that must
Now
be
what do
about
I
a
do?
RAM. Maybe I'm out of this.
You come to either me or Mike or somebody at DCO and you say, why did it die?
And then they'll say, oh, we don't have enough
Well,
RAM.
we'll tell you where to go usually. Unless you pay us.
Sadly, that's not true.
Yeah, unfortunately. Unfortunately. Okay, so
Wait,
what time do we have?
I'm leaving.
5 minutes.
Sorry,
5 minutes.
I'm leaving.
Okay. So,
-0 minutes.
so if there were more time, I would have you add the loop, the while statement surrounding all this, that would actually read the data from the input file and then test that out. And that would be a separate program, nothing to do with the one we've already written. And it's something that we've already done reading from the keyboard, but in this case we'd have it reading from an input file instead. We'll do that next time. And then given that, there'll be one more major step we need to do, which is writing the cost function. So turning all those numbers that we read in into some cost in dollars and cents.
Can we look at a calendar to see if we can change a day? Because we're
Sure.
going to end up not doing next Monday.
Sure.
The following 3 Mondays, I'm out because of my surgery.
Right, right. So how about Tuesdays?
It's
That's
fine
right.
with me.
So Tuesday, will you be here next Tuesday?
Next Tuesday I will be here, but what's that?
And perhaps Tuesday and Thursday? Maybe twice a week?
More frequently you do it, the more sick,
Because
the more you
it's clear that once
I
a week
know.
you kind of
It's
forget,
hard- Well,
right?
and I don't do the homework.
Yeah,
I
yeah.
have
So
my
once a
kids.
week doesn't really cut it
Let's see.
in
Good
terms
luck.
of retention.
So Tuesday and Thursday, of course, we're more on a reduced day because that's the day I pick up Connor. Tuesday and Thursday. Next Tuesday. I mean, I can but it's just a short day. So next Tuesday and Thursday do not appear to be the worst. 27th and 29th. Those actually would be okay.
Okay, how about you? Next Tuesday,
I can
Thursday?
do Tuesdays, yep, I don't have my Tuesdays in anymore. So, yeah, Tuesday and Thursday is good. Next week.
Okay, so we'll try next Tuesday and Thursday, but then it's going to be 3 weeks of nothing after that?
2 full weeks of
2 full weeks.
nothing, and then possibly the 3rd week is okay because I'm not due back until after the 16th,
Okay.
which is a Monday.
Okay, so we'll play it by ear. So at least next week we'll try it twice.
I'll get 2 classes next
see where we
week and
go.
from there.
Yeah.
Okie doke.
All right. Send me a reminder. Please.
You bet. You bet.
And put it back on.
Different day. We're all going to forget.
Yeah, because if I miss that much, I'm kind of done.
Yeah, exactly.
Yeah.
And since there's 2 of you, we can definitely fill.
All right.
Yeah, easier than I
As
thought.
needed.
Thank
Thank
you.
You bet.
Hey.
We're getting there.
Yeah.
Yeah.
What do I push on this thing to stop it?
The big button.